Okay, today we're going to take a look at the introduction to limits. Excited to present it to you. So let's go ahead and start. Learning goal. Students will be able to know what a limit is and how many ways to solve it. So by the time you're done, you're going to have a basic grasp of what a limit is and how many different ways you can solve a limit. Okay, so let's go ahead and start. Let's start with the question, what is a limit? So what is a limit? Now, the common sense definition, very simple. A limit is the intended height of the function. So I'll say it again. A limit is the intended height of the function. I think the key word here is intended because it might not officially reach that point, but it's going to get close enough to that x that you're approaching on the x-axis that you get a height. In terms of how many ways we can solve, there are 3 ways that you can solve a limit. The first one is called numerical. Now, numerical, basically you're using a table. So you construct a table of values, or you're given one, and then you can find the intended height of the function. In terms of the second approach, my favorite, graphical approach, you either draw a graph or you look at a graph, and you can see what the height will be at a given x value. And then the last one, analytic approach. I think you guys will like this one the best. It's using algebra or calculus to solve for the limit. So remember, all a limit is the intended height of a function. Don't let anyone else fool you. Very easy topic. So here below you can see that I have the 3 different ways you can solve numerically. What that looks like is you have a table, and then you could solve for what a limit is, and we'll talk about notation in a little while. The second one, graphically, you look at a graph and you look at some x value and you look up, and that would basically be the limit, the height, intended height of the function. And last but not least, analytic approach. So just using algebra or calculus. We'll go through all 3 in the next few videos. So let's go ahead and start with some notation. Basic limit statement. So a lot of the part of mathematics that gives people issues is the notation. Not a big deal. Just know that this little arrow means approaches. So this is called a basic limit statement. I like to call it a general limit. So that's the verbiage that I use. The way you would read this to someone is the limit as x approaches 2 of f of x is equal to 4. So let me go ahead and erase and do that again. Okay, so the way you would read this to someone is the limit as x approaches 2 of f of x, the height, is equal to 4. Very important that you know how to say it. Remember that the little arrow means approaches. Okay, let's take a look at our first example. It says, write each limit as a basic limit statement. Okay, great. Let me grab Mr. Green here. So basically we're going to write it as a general limit. Remember, general limit means the same thing as basic limit statement. The way I would write this is this: limit as x approaches, in this case I want to approach 2, of x cubed, and I'm not going to solve it. I just wrote the general limit or basic limit statement. Or you could write it this way. Let me grab a different color here. The limit as x approaches 2 of f of x. Now, if they don't give you f of x or g of x, you can't write it this way. So that's just a general limit or a basic limit statement. Very easy to write. Let's go ahead and let's take a look at another example here. Okay, example 2. Graph and find what the limit is equal to as x approaches 2. Okay, this is a cubic. And a cubic, this is just a rough sketch, so bear with me here. Looks a little something like this. and I want it as x approaches 2. So 1, 2 on the x-axis. Now, what a limit is it's basically the intended height of the function. So let me go ahead and write it as a general limit real quick. Limit as x approaches 2 of x cubed. Okay, so it's really tough to see because my drawing is not perfect here, but basically what I would do here is I would try to approach from the right and from the left to see what my height will be. Remember that I might never ever reach 2, but I'm going to get really, really close. Now, what you could do algebraically is just simply, the function is x cubed, plug in a 2. 2 cubed is equal to 8. So even though my sketch doesn't look like it, this value would be 8. So the limit as x approaches 2 of x cubed is equal to 8. Remember that in this case, because they gave us f of x, you could also write it like this. The limit as x approaches 2 of f of x is equal to 8. We'll take a look at more approaches in the next few videos in terms of graphical. So don't stress out if you didn't get it completely. Just a little intro. Okay, so solve analytically. Now this means we solve using algebra or calculus. Now I kind of already introduced this just a second ago in part A, but I'll run through it again. Limit as x approaches 2 of x cubed. Okay, so we're going to use something called direct substitution. All you do is you substitute in the 2 in for x. And what that looks like is this. Limit as x approaches 2 of 2 cubed. Now, technically, once I evaluate the x, I no longer need the limit. So I'll say it again. Once I plug in for x, I no longer need the limit. The limit just tells me that I'm going to basically plug in. So 2 cubed would make 8, and so we could say that the general limit as x approaches 2 of x cubed is equal to 8. That would be our answer. Okay, so I do feel that we had a nice little intro. Let's take a look at our learning goals. Students will be able to know what a limit is. Remember, it's just the intended height of a function. And how many ways to solve it? There are 3 basic ways. We have the graphical, which is my favorite. We have analytic, which will probably be your favorite. And then we have numerical, which is using a table. I'll see you on the next video.